All right. Welcome back. Hello. It's your first time tuning in. I'm Agent Ultra, and I'm here to hack on some Haskell action. We are working on wave function collapse. So we've been working on for a while now. On this stream, I mainly do functional programming in the programming language of Haskell. And yeah, we're learning about wave function collapse, how to implement it, how it works, all that kind of stuff. And like how to implement it in Haskell. We're using that as our learning language here for that. So yeah, let's jump right in and get to the code. I believe last week we got it like mostly somewhat kind of there. However, we wrote a small test. Ooh, yeah, so I need to make the font a little bit bigger. Somebody mentioned that actually on my YouTube channel. So I'm going to start with doing that first. Let me actually customize. I forget. I always forget how to do this in Linux. Gotta be in faces. Yeah, I'm gonna look it up, Google it. I know how to like change it dynamically per buffer, but yeah. Set face attribute. Oh, customize face. Okay. I want to set them all. Size. Postscript. No, no, no. 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 La, la, la. I think I'm gonna go with this one. I might even have it in my Emacs already. Personal. Edit. That's done. Okay, I'll put it near the top. Here. So height 100 will give us 10. That'll give us plenty big. Hopefully that's big enough on the screen. Maybe not too big. For me. You'll have to tell me, chap. Do. Okay. See if that works better. Okay, so code. Let's get to it. Run wave function collapse source algorithm. There we go. Okay. And basically, when I run we came up with the test function. It's kind of like more like a just make sure we don't hit any of the exceptions that we've set up for ourselves kind of test. And that's this one here. Describe run wave. So we just want to check that, like, when we run the algorithm, we get a different. The output texture has been changed from the input texture, so we generated something. or the final state wave grid is different than the initial wave grid. And that'll be a protector, the wave grid. And that should just exercise the algorithm for those exception cases where we have kind of like put little foot guns for ourselves with these calls to error here. Some of these shouldn't even be possible to reach if everything's working properly. Right. We're like choose cell here. I don't think we should be able to get there. Maybe we should be able to. Anyways, but yeah, that's the general idea, right? And so when we run those tests, though, we get a problem. Where I'm going to make the font on this a little bigger as well. On the terminal. Font size. Hopefully that'll be big enough. Okay. Where we run, and we'll run with our file watcher. And basically we run into a failure case right here, right away. We run into one of these filter possibilities, invalid adjacency rules. Okay. So we really, I don't think we should even be hitting that error case. That's where we hit it, when we're checking is enabled. So we're getting the adjacency rule for R out of our adjacency rule map. R is the pattern B, direction, adjacency rules. R. Yeah, so we're getting the map out of that. We're getting the adjacency keys. So pattern A, pattern B, and D is enabled. And probably shouldn't be able to get there. This basically means that we're looking for an adjacency key that isn't even in the map. And when we generate the input data, all that map should be complete. Have all of the possible keys in it. So I think we shouldn't even be able to reach this. So constructing this is enabled. We're constructing this adjacency key. Okay, so there's the possibility that we're either we're not producing the adjacency rules map properly, which is my initial suspicion, or we are, and we shouldn't be able to get this adjacency key. We've got these flipped around. An easy test would be to just flip them around. Let's see if that goes away. I doubt it. Yeah, invalid adjacency rules. We're getting more of those, yeah, so that's no good. 5 failures. I guess because we shrank. Yeah, no, it's just wrong. Just plain old wrong. So I'm thinking it's the input there. There we go. Just the one failure is good. Okay, because these are all, we're constructing these perfectly, these examples, so that makes sense that those pass. So we're probably not generating them properly. Or we're missing some when we're generating the adjacency rules. So let's take a look at that code. Generate adjacency rules. Okay, so we take a list of patterns as our input here. We generate the adjacency rules, which is essentially a map, right, of an adjacency key to bool, whether that's allowed or not. An adjacency key is a pattern A and a pattern B and a direction. The Boolean tells us whether they're allowed in that direction, whether pattern A and pattern B are allowed in the said direction. Okay. What we do with the patterns, input patterns, so we take X here and Y to be each pairing of pattern indices. So this would give us, for each X0, so we have a 0, 0. It might be this. It could be this. I think this would be 0, 0, 1, 1, 2, 2, and just give us the diagonal possibility, in which case we'd be missing some. And then we fold with add rule all over the adjacency rules. We give the empty map there, pattern indices. And when we add a rule, we take the rules so far, that's what we're accumulating into, a pair of pattern indices. And then we fold over that for each direction into the adjacency rules. And then when we add a rule for that direction, we get pattern A out of patterns, pattern B out of list of patterns, and we check the overlaps, pattern A, pattern B, in direction, and then we either allow it or else we don't do anything. And as long as we initialize everything to false, that should work. So I think it might be pattern indices there. Do a little debug.trace here. Just to see what that is. Just add that. Oh, it's already there. Okay, good. We'll need to show. There. Okay, dokie. Let's see what we get. Okay, we do get all the pattern indices. 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then we get 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. So we could be getting a bounds. 115, okay. Now our test, maybe it's a bounds issue. I don't think so. That would be a different error. Maybe our test is texture would be 16 by 16, so 0, 0 to 15 by to 15, 15. Yeah, that makes sense. Okay, so that is all the pattern indices. Okay, so maybe it's our fold. In which case... that's what I call make wave state, we call it there. Okay. Just 1 second, please. Be right back. Okay, right back. Okay, so this basically means that it's got to be maybe the fold that we're creating. So let's check that. We will call it foo. And that here. And then I can debug trace, show foo, and we'll just return foo. Okay. So we have a pretty big map. I think we should end at 1515. We do 1515, pattern A, pattern B, and direction left is allowed. Pattern A, pattern B, and direction right is allowed. Uh, 1514 down is allowed. 1514 up is allowed. Hang on, this is looking a little fishy at the moment. Let's see, key, so we got 1515 right, 1515 left. We don't have 1515 down or 1515 up. Let's see here, we've got 15-1. Pattern B15. They're not in any particular order, I guess, so I printed 15. Let's see, do I have a find? Control Shift F, oh good. Do 1515. Okay, there's one. There's only two. Okay, there is only two. Alright. Well, that's not good. So yeah, I guess it's our fold is not quite right. It's not developing the adjacency map we want. Okay. So let's see here. Fold L over here. We're folding over each direction. We're adding rule 4 AI X BIX Rs. Ah, it might be here. It might be here. We don't modify ours here, and ours is initialized to the empty adjacency rules map. That might be an empty map, not a pre-generated map with false in it. So that would be an error. Right, we have allow. Allow and allowed. We should have a disallow. And I think probably with the same type. Mac that over there. This allows kind of the opposite of this. It's pretty much the same, except this is going to be false. We could probably clean that up and compress that down to one function, but and pass in this as a parameter, but we'll leave it that way for the moment. Let's see. Just want to make sure that actually did. Okay, 1, 2. Oh. Still only generating 2. Oh, we're not actually using disallow yet. That's fine. There. So if we disallow AIX, BIX in direction R's prime. Okay, we're getting a completely different error. So we're running into another one though. It's not great, but that means our adjacency map, at least that part's working. Jason's key pattern 8, yeah, 1515 up is false. 1515 right is true. 1515 down is false, and 1515 left is true. That's good. Okay. So are we done with this yet? Not quite. We could compress this down to one function, or we could just leave it. Having too many names can be a bad thing sometimes in code. A lot to keep in your head at once. This might be... I think allow and disallow is actually kind of nice. In this case, it's like, it reads quite well. Right, if it overlaps pattern A, pattern B, then allow that pattern. Otherwise, disallow that pattern. That's pretty alright. Otherwise, we'd have some kind of generic sounding name where we'd be passing in a Boolean, and that might not be quite as nice. I'm gonna keep that. Alright. Tests are still broken, but we still commit that. Okay. Let's see, what next shall we do? We got to look at this next error, which is get cell at. That one probably should also not be possible. Alright. So get cell at is looking at the grid, trying to get cell at, and is finding nothing. We call cell at with the grid. We use this maybe at function. We get the cells from the grid and go maybe at. And maybe at is looks at an index in the array and maybe finds that thing in the array. Right. So we use array in range, the bounds of array for that index, I, here. And then if it is, then we can safely use array.bang to get that thing. Otherwise return nothing. That seems legit. Like I don't think that has any errors in it. Let's try module plus data.array. Maybe at We'll do already list array 0 to 3, 0 to 2. We'll do A, B, C. And we'll try to get index 1. We get just B. And that seems about right. Just A. And if we do 2, we should get just C. But if we try to do 3, we should get nothing. So on and so forth. Try to do -1, we get nothing. Okay, so I don't think it's that. And that must mean, yeah. So that's fine. Cell add is just calling maybe at, so that looks fine. Well, it's got to be that we're passing in a bad index here, like an out of bounds index to get cell at, whatever we're calling it. Calling it in a few places here. Modify cell at, get neighbor removals. That could be a candidate right there. But it says it's at 616. Oh, that's where it was. Yeah, not sorry, that's not a traceback. DDD. So it could be any one of those calls, essentially. Not too many of them to get searched through, so let's see. Modify cell at, get neighbor removals. That's a potential one. Although it's getting it from remove cell index. From directions. This calculates a grid direction, and maybe it's returning an out of bounds one here. We can just get trace M here to excuse me, show remove cell X. See if we get what we get. And there we are. Yeah, that would hit nothing. There's no -1 in our space. Which means from direction it needs to do some wrapping. In fact, if we check it here, with the grid width, grid height, we buy a map. Yeah, so in the case of up, we're getting to -1. -1 in the X component, looks like. So it would be either left or right. So we say if x prime, it could be x minus 1. Then x prime, if x prime is less than 0, and we want the grid width minus 1. Else x prime. So x prime could be 0. Shouldn't be anything less than 0. Could grid width maybe become 0 here? Possibly. from direction left. And we'll show grid width. See what we get. Okay, grid width is getting to 0. We are getting a 0 for that value, which makes sense, because 0 minus 1 is negative 1, of course. Okay, so our function, our calculation here to get the rate out bounds from the grid, I call second on each element, is not quite what we want. So looking up data.array, let's pop over here. The type of bounds takes an array IE and returns an II. So the I is the index. So it should be this. And in our case of the grid as being a 2D grid, and because we're calling bimap on it, it should be the second element of the first and the second element of the second, because it's bimap. This is not what we want. This is the problematic function. Okay, so what we actually want here, let's create an array, kind of like ours, 0, 0 to 2, 2. We're going to put A, B, C. And another one, another row will be D, E, F. And the final row, G, H, and I. Alright, bang, bang, bang. Cool. Okay, so if we get the bounds of A, we get this tuple 0, 0 to 2, 2. And if we did bimap, do I have that in scope? I gotta check if I do. I do, okay. If we do bimap second over A. Oh, sorry. Bimap over bounds on A, we get 0, 2. It's not quite what we want. No. If we just take the second of bounds, then we get 2, 2. That is what we want. And that should give us to 2, 2 there. So we recheck our tests here. We're good, we're good, we're good. We're not hitting any errors so far. We might not be able to generate something here. That would be another kind of error. But it looks like it's progressing. And not hitting our edge cases at least. Okay, we're just progressing infinitely now. I'm gonna stop it there. Get rid of these debugs. Okay, so that... If there's other bugs in the other expressions, that should fix the rest of those. Yeah, we just gotta get rid of that. Okay. And oh, I left a debug trace that I didn't want to in there. Okay, let's get with that. That's better. Fix error. And from direction. Okay, and now let's look at what our algorithm is trying to do here. So we're basically progressing infinitely. This was the debug trace of looking at from direction. We're getting neighbor removals. Actually, I kind of want to... Where was it? Yeah, it was here. Yeah. Yeah, it was that one, right? Okay. Wonder if the infinitely many regression is, you know, our propagate step here. That might be that we're not popping off the stack and returning the changed stack to the state somewhere, perhaps. Okay, we can probably get rid of that one too. And the commented at once. Okay, we'll get rid of that. And that there, that there. Get rid of this line. Beautiful. Yeah, I think it's just progressing infinitely, yeah, not making progress. Okay. Okay. Yeah. That's what I think is happening. So something isn't decreasing and getting to its termination step, so that we can finish. So we should either hit like if we're decreasing too far, we should hit 2.7. This one. Collapse at. This to do might be worth poking a nose at. Yeah, okay, we're gonna cancel that. And, yeah. Something like that. Okay. So, overview to remind ourselves. All right, so for some initialized output grid of cells, Okay. We're going to do here. So we have our init wave state and all that stuff. While there are uncollapsed cells. Okay. So I think this is what this is supposed to be doing here. Remaining cells. Right. Yes, the remaining cells from the wave state. It's possible this might not be... Maybe this is the thing that's not decreasing properly. It looks like in the output, when we were printing that out in the neighbor stuff, it was cycling through the same ones. I'm trying to remove those. So it might be further down. But we probably... I guess we're probably not getting here. Collapse wave, remaining cells. Yeah. Try that. That might just stay at the same number. We get one number. And then 100, yeah, and then it doesn't change. So we never actually get back to, yeah, that means it's further down. Right, so that means we're getting here, it's greater than 0, we're going into propagate collapse, we're never getting to collapse wave, and calling this back again, otherwise we'd get to this line. So it's in propagation somewhere. So let's go down. Propagate collapse. Okay. We choose a cell, we collapse at that cell, and we call propagate again. So, if this one is looping, we should see something here. Propagate collapse. Cell X. Right, we should be seeing a bunch of new cells here, but I'm probably right about this, but I'm guessing that we'll choose the first cell index, and then it's somewhere in collapse at that will get stuck in our infinite loop. Let's test that. Yeah, see, we're choosing cell 1, 3 on our first call through the loop, and then we're not progressing any further. So the loop is going to be further down. Okay, collapse at. So we get 1, 3 here. We get the wave state out, and let's see, we get the cells out of the wave state grid. And we use maybe add again here. We get 1, 3 out of the cells. It's not invalid, otherwise we'd be getting this error branch, so it's over here. Okay. We get a collapse cell and a removal pattern. It might be this 2-2 that I had crossed earlier. So basically, we get a new grid. To get a new grid, we take the cells, we update the array at that cell index with the collapsed cell. We set our pattern stack up with the removal pattern we got. Then we modify the state such that the wave state grid is the new grid, the remaining cells is decremented, the pattern stack is pattern stack prime. Okay. There's a few things going on here. Probably either in collapse, probably in collapsed cell. Let's jump down to collapsed cell. We pick a pattern index based on C. So we pick a pattern index from C. And then we return a cell and a removal pattern. Collapse the cell possibilities. Cell collapse is just pattern index. Total weight, total cell leg log, remove pattern. Okay. Could be here. Alright, collapse cell possibilities. That one looks pretty straightforward. And go. Go. Where's go used? Is go even used? Oh, it is, yeah. Yeah, it's used by patterns. Okay. So what does go do? Go recurses on a list of P's, and when it can't find any more pattern indices, that's where it errors out. So we're not hitting that. So the natural recursion on go does decrease here on line 504. That should eventually terminate. I'll flip that around so that's actually in the tail position. I'm not sure that matters here. Swarm Collective, how's it going, friend? How you doing? What if weight is 0? Right. Then remainder probably never be. There. So that's a possibility as well. We might not terminate there. Okay, so we got a couple of candidates here. Thanks, friend. Thanks for stopping by. Okay, we could easily tell if collapse cell does terminate here just by bringing this out. It's probably not. Yeah, we'll do that. And we'll do the removal pattern. We're almost there, Swarm Collective. I can feel it once we get through these. Okay, so we do get past that. So in our first case, our first collapsed cell was at index 1-3, I believe, in the grid. Its possibilities. Everything is false. There should only be one true element in here. And that is 11. So we picked 11 to be the pattern. Just 11, that's set right. These get recalculated at a different part of the algorithm. And a removal pattern. Okay, this could be causing things to happen that shouldn't be. think that might be important here. Yeah, I don't think the removal patterns are being initialized properly, which is probably what's causing the issue here. Yeah, I think it is that to-do. So the removal patterns are where we are scheduling possibilities to be removed from neighboring cells after collapsing this one. All right. And so we want to remove, we picked 11, which means we want to remove from the neighboring cells in the various directions all those patterns that mention overlapping with 11. Because now they can't be picked, or no, not overlapping with 11, because they can't be picked anymore as potential possibilities in the neighboring cells. So we're not removing 11 from the neighboring cells. So I think this is wrong. Essentially, I think this is the problem here. Let me just cancel that. It's probably just chugging along infinitely many times. Okay, okay. Get over my little dooey bug. And this is collapse at. Org. Link. Oh. Ooh. There's that's link store link CL. Yeah. There we go. Okay. Bugs, yes. So collapse that bug. And okay, this is just a handy dandy little thing that org has where I can create links to files. Okay, so the collapse that bug pattern stack not initialized properly. Remove disabled. Remove patterns no longer enabled by the collapsed cell. Hopefully future me will be able to parse and understand that. And yeah, wanted to get that from here. And I'm going to just put that as right there. Best. We get that, and we got this bad boy. Like there. This cell possibility is this one here. We'll test cell possibilities. And we get the pattern stack. Oh, okay. Okay, so let's see. What we need to fix this, I think, is to use, if assuming our function for collecting the neighbors is implemented properly and has no errors. Get neighbor removals. This is the function we should use to initialize that list of remove patterns. Okay. I think it was 3 arguments, if I wasn't mistaken. Int, that's the one we just removed, so that should be cell X. And the pattern index that we're removing, I think we have that in scope. Stack, pattern removal, upsell, expand, no, it's not good. Okay, let's look at the source. We get it. I guess we get it through the collapsed cell, the pattern index that we chose. But we get it wrapped in a maybe, which is super annoying. So what I think we need to do there is update collapsed cell, perhaps. To return the pattern index that we picked. This should just be removed. Shouldn't return the remove pattern. Just pattern X. Pattern index, okay. Okay. So then we change this. Pattern index we got back. That, and we could pop it in here. And our next hole is a direction. So we're going to need for all of the directions. Right? We're going to need all the directions, and then blah blah blah, flatten that list. Mm-hmm. Not right. I think we have a variable directions. And then pattern stack, state, wave state. 2, so that's not quite what we want. Unfortunately, with this font size, it goes way up to the right, and for some reason I can't roll over there. Okay. Maybe we get a print it out this way. There we go. Yeah, it's list remove patterns, and I think we're gonna have to bind this. That should be, yeah, this. Okay, that's good. And we can flatten that down. Okay, that compiles. So let's bring the test back up. See if it makes progress now. Oh. Okay. So, still not making progress, but I think that did make things better. Okay. We do get past here. We do upgrade. That should work. That shouldn't be it. So it's probably get neighbor removals itself. Yeah, that's probably the last place it could go, right? If we never get to hey, 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 hey. Oh, we do. Interesting. Okay. Okay, that's interesting. How are we getting there then? Laps at pattern stack. Pattern stack is used. That should be forced. Let's take a look at that. Okay, so this is our initial remove pattern stack. So it wants to remove pattern index 0 from cell index 1, 2. It wants to remove pattern index 2 from cell 1, 2. So it'll be kind of hard to figure out if this removal stack makes sense without also looking at the adjacency rules and kind of going shinga shinga. I think if we could maybe we can assume that makes some sense, and this is right. It's still, maybe it's just taking a long time, but it's actually making progress. It's kind of tricky to know. Okay, so we call that, we modify the state. So after we call collapse at, we call propagate again. No, we call propagate. So it could be in here. Okay. Alright, so let's do this. So what one are we going to be removing first? Removal. Okay. So when we propagate, then we pop off the remove stack. So this is after we've collapsed the cell. Go to propagate. Pop one off the stack. If there is nothing, then we're done. Otherwise, there's a pattern to remove. So we eliminate that pattern. We call propagate again. So one way we could tell if this is going in an infinite loop is if eliminate is actually decreasing the size of the stack. So we never reach the nothing case. Or propagate collapse never calls again. It's propagate collapse. Oh wait, once propagate returns, yeah, propagate collapse should return as well. And then we should get back to collapse wave and get to remaining cells. Okay. So I'm going to put a debug trace up here. And I'm going to put remaining wave cells here. And so we know we've broken out of the propagate loop if we get more than one of these messages. We need to show on that, of course. Booyah. Nope. Almost. Okay. Now the booyah. There we go. Okay. Okay, so back down to collapse, to propagate. Okay. And let's just check that out. Because we could be just propagating infinitely. I think we're getting close. We are... Okay, we're propagating a lot. Now, we would know if we're propagating infinitely if we get like a cycle. Here, like we keep propagating the same ones over and over and over again. Which I think could be happening. So 0, spell pattern 0, 3, 4, 3, 4, 3, 4. Oh, actually, this might be progressing just fine. So then we remove 1, 3, 5, 7, 9, 11, and 13 from 2, 5. It's 2, 5, 3, 4, 2, 3. 1, 4, 2, 5, 3, 4, 2, 3. 1, 4, 2, 5, 3, 4, 2, 3. But then 0, 3. 1, 4, 2, 3. 2, 8, 4. Yeah. It might just be taking a while. Okay. Maybe? Let's just double shake eliminate. So when we get to eliminate, we'd get the frequency hits out here. We modify the cell at remove pattern. We remove the possibility of that pattern index from the cell at this location. All right, so when we see one of these, we're removing 15 as a possibility from the cell at 2, 3. And then we get the neighbor removals for each direction from the propagated cell index. So we get the neighbors of 2, 3, the ones that we want to eliminate, based on this 15 that we just removed as a possibility. And we push those removals onto the neighbor removal stack. That seems pretty straightforward. I think that's what we should be doing here. We can see here, modify that cell. Assuming neighbor removals, and I think we've seen that doesn't have any cycles in it, so that should also finish and push the removals onto the stack. Okay, it could just be it's just going pretty slow, and there's like a lot of work to do. So let us just let it run for a little while and see how we do. Maybe if it's too slow, maybe we'll start with a smaller, even smaller output grid and input. I'll just speed that up. So this example we took from one of the tutorials we've been kind of like comparing our stuff against. We haven't done it in a while, so maybe we should go back and look at it and kind of compare results here. See how well we hewed. Maybe there's some mistakes made in this. Okay, it's still taking a while, so let's cut that. Let's make the output grid even smaller. Say 6, 6. That's 100 again. Oh, the seed. Okay. I'm just gonna call that seed 100 so that I remember that. Seed. Okay. So if we make it smaller, does that work? What else could it be? It could be that the stack just isn't ever decreasing. We just keep adding new removals to it. But the way we're propagating, how could we detect that, though? Let that run for a little while we look at, and we just try and figure this out from the code. Let's see if we can spot what's going on here. Remove possibility. Yeah, this is where we update the cells, weights and stuff. Oh, look, I did finish eventually. Here's a failure -9 though. I guess there's just like a timeout limit there in our test runner. I suppose. Okay. So it never actually did really finish. Or maybe it's just taking so freaking long that our test runner isn't even waiting. Let's make this pattern, the output pattern grid, even smaller. Ooh, a ridiculous size. Okay, so it probably is some kind of something to do with the stack never being exhausted. That's my guess. Okay, so when we call remove possibility from eliminate here, this to do is interesting. So rename or fix me. It seems to have already picked the remaining by collapsing before calling this. Possibly. Okay, so even on the small size, it's still kind of going over time there. Okay. So it's not the size of the output grid. Put that back to 10 then. But it's still small. Okay, so it is something with elimination. We're pushing more removals on than we ever pop off, and we're doing that continuously. Okay, we have to figure this out in order, and once we unlock this, I think that's the end, because eliminate is basically at the bottom of our branch, the very leaf thing that we do. Okay, so let's see. We know we're popping the removes off. It could be that get neighbor removals still has an error in its logic somewhere. Or that we're passing in the wrong parameters to it, and that we're basically always adding more neighbor removals. And we never actually decrease the size of the removes of the stack. So let's get the stack out of the wave state. Wave state. Wave state. It is called the pattern stack, remove pattern stack. So let's just call it S. And propagate S is the length of S, really. What I'm going to go for. If we see that stay the same size roughly, or like only increase, that means, yeah, we're kind of going backwards in the wrong direction. I mean, it should increase a little bit and then go back down again and eventually get back down to 0. Sorry, missing a little doohickey there. Yeah, see, it's only going up. It's adding. We're just adding and 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 adding. Okay, so there's our bug. That's our error. I expect that stack to increase a little bit and then eventually come back down. So that's the problem. Let's go back to my to-do file. Okay. That one's done. Next one is propagate or eliminate. Maybe we'll do it at the level of propagate. Control CL, there we go. Pop it there. Okay, here. The stack size grows indefinitely. It should eventually reach 0. Swarm Collective. Is it possible that the same operations are being added over and over? Yeah. Could be. Could be, yeah. We could add a way to, like, check the ones we've removed so far to make sure that we don't get any duplicates. Or at least just as, like, a little bit of debug code to get us there. Thanks for the tip, buddy. Friendo. Okay. I'm suspecting it's maybe the neighbor removals isn't quite right. Yeah. Yeah, exactly. The semantics of the... Yeah, I want to say the semantics of that is not exactly super clear. I'll get neighbor removals. For a couple of streams there when we were working on it, I was getting a little bit... I was flip-flopping around on like how to interpret everything, and it's not really well specified, probably. Although we do have a pretty good test suite for it, if I recall. However, there is something wrong with it. I think that's probably what it is. Oh no, we don't have a test suite there. That's probably our main problem. Okay. That would probably fix things if we had a test for that. So I suspect you're right. Something like that. Either that or like the modify cell that's not really doing it for us, but I think it's this. That's what push removals is what's pushing onto that stack. So okay. So let's test that theory first, because I think that's going to be pretty easy to do. We can add something to wave state temporarily. is wave state scene removals. And I think we have containers, so I could probably make this a set of remove pattern. And so we can add port data.set set. And import qualified data.set set. Okay. All right. So jump down here. Yeah, propagate. We'll do it here. Scene removals. So we'll do scene removals here. We'll get it out. We'll do the query here. Wave state scene removals. And if we've seen that removal, removal is set as a member of scene removals. Then what we want to do is we want to screen. We'll just cure and do. Get rid of that. We have to look at that. Or debug.trace that, actually. Ooh. Oh, right. Maybe remove pattern. Sorry. So I have to move this down here. Okay. Otherwise, after we do that, we should update the scene removals with the one that we removed. After eliminating, perhaps. State where wave state scene removals equals set.add, I think. Something like that. Insert A in set. So we'll do removal. Remove pattern, sorry. Remove pattern. Insert into scene removals. That's because I did the wrong one here. New pattern. There we go. We need an ordinances for remove pattern in order to use sets. We might just want to change that to this then. Well, we should be able to derive an ord at least temporarily. Scene removals. Yeah. Tons of them. Tons of them. Okay, so there's definitely something wrong with Get Neighbors. So we're just constantly removing the same ones over and over again. Okay. Well, that's a good hint that we're on the right track. We're getting close to the end of the stream, so I don't know if we're going to squash this one today, but hopefully we'll make some progress on it. Okay, so we'll leave that in there for now while we work on this. Because we shouldn't see any BAWs if we fix it. Okay, so let's start, though, by writing a spec for Get Neighbors. Right? Okay. Get neighbor removals, I should say. Get neighbor removals. Okay. So. In Get Neighbor removals, we get a base cell index, a pattern index, and a direction. Returns a list of patterns to remove. What we want this to do, or well, let's just look at what it does. But what I think we want this to do in terms of eliminate is return the list of patterns that are no longer enabled. Yeah. It should be. Let me just draw this out a little bit. So it helps when you draw out the grid, you kind of look at it. Okay. We have a grid. Yeah. Okay. And at this cell here, we have collapsed it down to the value pink. Okay. And let's say we have some adjacency rules where pink and say yellow. Yellow is allowed to overlap pink when it is to the left. Something like that. Maybe if I put the L above the arrow there, it'll kind of make a little more sense. So yellow is allowed to be left of pink. All right, so yellow is a possible value we could pick for this cell here amongst the others. All right, but if say blue is one of the possibilities here. And this was the only rule we had. It's probably going to be more. Right, that means we can't pick blue as a possible value here anymore. All right, we can't pick blue here. We want to get rid of blue as a possibility. All right, so we want to schedule blue at this cell location for removal from this cell. When what removal means is remove this cell from remove blue from the set of possibilities for this cell at this location. Okay. So that's kind of, and get neighbor removals for this direction. At least let's start looking. That's what it should do. Okay. So let's look at what we got. Right. Gets the grid, gets the remove cell index. So from direction, grid, takes the base cell index and the direction. Right, so that is trying to calculate, again, assuming from direction is implemented correctly, is trying to get the index of this cell over here. Right? Put that here. This one. Right? It's trying to calculate that based on the direction from the base cells index. Okay. Then on the next line on 578, we get that cell at that remove cell index. So we get that there. We get the adjacency rules from the wave state. Then we return. Okay, there's another place where we could have an error here. Not enabled means is looking for in this cell based on the adjacency rules, the pattern indices. I think there's a mistake that's coming out, kind of making itself obvious to me at the moment right here. Okay, so not enabled should be doing this part where it's looking through our list of rules and seeing which ones are not able to target pink based on the direction. All right, because we know the direction left, that's our input here. And we know pink is the pattern index where we want to remove. Or maybe. I think so. Maybe that's the mistake. Maybe that's a possible mistake here. There's a pattern index and a direction. And the base cell index, that's the direction. So we need to get that offset there. And so not enabled should be looking through the list of possibilities where pink is pattern B, the target. L is the direction. And it's true. Or should be maybe false actually, yeah. Okay. I think maybe that might be it. Alright, so not enabled should be getting the rules where we cannot pick the value in pattern A from the adjacency map. That's what it should be doing. Pattern to check, direction, the rules, the cells. We get the possibilities. Cell possibilities. The second value is whether it's possible or not. We only take the ones that are possible. Swarm collectives asking, not allowed means not allowed. Not enabled. Yeah. It's the opposite of enabled. So enabled means that I can pick the pattern A to the target because it overlaps. Right. Not enabled means I cannot pick the pattern A because it doesn't, it overlaps with our target value, but we're trying to remove that target value. So it's not possible to pick the pattern A anymore for that cell, for this cell. All right, so if we're picking pink, the direction is left. Pink is going to be our pattern B. What we're trying, and we're trying to look for all the patterns that overlap with B, and that are enabled, that are like that are overlappable. Right. That's what I think. That's what we want, because they're no longer. Because we're trying to remove pattern B, they're no longer enabled. They're no longer valid. The pattern A's that overlap with pink, the colors that overlap with pink, are no longer able to be. Or no, those are the ones that are able to be chosen. Anything that we can't pick. Right. Yes. All the ones we can't pick. So where we can't pick because it doesn't overlap with, it's not allowed to overlap with pink. That should be eliminated already. No, yeah, those ones shouldn't be able to be picked. And yeah, those are the ones. This might be where the bug is, because I'm clear. My thinking is clearly not very focused here. I'm clearly going back and forth. So let's actually try specifying not enabled instead of get neighbor removals. Let's go a little bit lower. Make sure I do have not enabled. Okay. Okay, we do have a spec for not enabled, so maybe it's not here, but let's see what I thought it was. Given two cells with two possibilities, one possible. Okay, so this is our adjacency map. And I believe the way this works is like, this key here, 0, 1, up, and true, means that 0 overlaps 1 in the up direction. Because that's true. That's allowed. And then we check 0, 1 overlaps in the down direction, that's false. 0 overlaps 1 in the left direction, that one's false. And 0 overlaps 1 in the right direction, that one's false. So in only one case can 0 overlap 1. Be adjacent to whatever you want to put in. Okay. So they're given this cell, and these are the remaining possibilities. So 0 and 1. And 0 is a possible one we could pick. 1 is not. So 0 is the remaining possibility that we could. So it's basically collapsed. So this should be actually, technically, this would be just 0. And then if we call toRemove not enabled 1 up rules and cell, we're saying toRemove should be 0. So it should return possibilities that are not enabled. Now, maybe it might help if we define what enabled means a little bit more precisely here. So a rule should be enabled if, or a value, a possibility should be enabled if there is a rule that allows it to overlap with our target value possibility. And not is just the not of that. Okay, so this means we're trying to move 1 in the up direction. I don't think these tests make any sense. I think they're wrong. Okay, I'm gonna go with this. I'm gonna try to specify what enabled means here. Right, so given a pattern index, a direction, adjacency rules, and cell, return a Boolean. Target index, direction, rules, cell. Okay. And now, what we want here is to look for, what does this even mean? Enabled. Then bool doesn't make sense. It should be a list of pattern index. Or if maybe if we do want a bool, then we have to give 2 pattern indexes, right? I think that's the only way that makes sense. Give me 2 pattern indexes in a direction. I'll come up with the adjacency key. I'll look in the adjacency rules. I'll take... Oh, the reason why we want the cells. Okay. We don't need the 2. But we do return a list. Pattern indices. Okay. And so the pattern index is the target pattern index. And we're going to go through the available, the active possibilities, the cell's possible pattern indices that we could still pick as values here. The remaining possibilities. right? And this pattern, this list here is gonna be the list of pattern index from remaining possibilities that overlap with target X in direction. Right? Because those would be the ones that we could still pick as valid values. And then not enabled is the opposite of that. So this would be the list, this pattern index would be, hey, Elemental Magic's card game, what's up? Haskell is going well. We're actually just working out the logic of this, this algorithm here. And hopefully it's the last error in a little bit here. We'll have wave function collapse going, and it'll be super hot. It'll be great. Magical. And who knows? Maybe we'll use it as a library for future game projects on the stream. Okay. The opposite list of this of the enabled list would be the pattern, the available possible patterns we could pick from the cell that are no longer valid values to pick for pattern index. If that makes sense. So let's look at enabled. The list of pattern indexes from the remaining possibilities that overlap with our target. So let's get out the possibilities, the remaining possibilities from the cell. Do I have a function for that already? Remaining. I saw it. Remaining cells. No, that's the count. I should probably have a helper function for that. Yeah, so why not? Cell remaining possibilities of the cell, all right? Okay, so we have that in scope. And now we still need a list of pattern indices. We have still use remaining possibilities and the other variables here. Okay, so of the remaining possibilities, we could treat that as a list of pattern indexes. No, adjacency keys. No, that would be a list of pattern indices, yeah. That's all that's available in the possibilities of the cell. Okay, yeah. So the remaining possibilities, and then we can construct our list of adjacency keys we want to test in adjacency rules. Yes. I am slightly Elemental Magic's card game is slightly reminded of an optics tutorial that shows the use of Bazaar for Game of Life. Yes, that could be interesting. So the use of bizarre for game of life. I'm not sure what you mean by that. But I think I've seen an optics tutorial that used optics or lenses in Haskell for implementing game of life. Which might actually make some of this code that I'm working on cleaner. I like lenses. But sometimes I stick to like the gross ugly code and then introduce them later. Some projects I've used lenses up front. I don't know. I do like lenses, but just simple use of lens. It's probably going to be something like that Storm Collective, yeah. Yeah. Okay, I've already had this thought then. Okay, so I have implemented is enabled. And then I take them only if they're enabled. This is weird. This code is super weird. I don't know what I was thinking here. So this is saying that the list.nub just like removes duplicate elements from the list. We're taking elements of P from possibilities. This here, this expression. And checking if that's enabled in the direction given the rules for that possibility P. And if it is, then we add the first element, the first of P. So that's the index into cell possibilities. So that's pattern indices. All right, there. So we want not enabled. Maybe it's as simple as just nodding this. Like taking the negative of it. No, I'll just put it all there. Could it be? Could it be? Let's try. Let's run our test. We should not see any ba. No ba. Now we're still getting bas. And we're probably still getting ever increasing stack. So let's see how does is enabled implemented here. We take the pattern B, that's our target for the rule. And pattern index bool, so this is only the patterns in the remaining possibilities of the cell that are true. That means they're possible candidates. So we get the adjacency rules as a map, and we construct the adjacency key as pattern A. That's the remaining possible one we could pick for this cell. And pattern B, which comes from pattern check, the one we're targeting, and the direction D that we get. DIR, yeah. And if it's nothing, it shouldn't be, which is why we have the error there. Then we get it. And it's a Boolean. So that would be... This Boolean means that A is allowed to overlap with B in this direction. Okay, so the remaining possibility is allowed to overlap with pink. This remaining color is allowed to overlap with pink in this direction, say left. That means if we take the negative of that, it means that we don't want this and remove it from our list. And we should only get the remaining possibilities, which isn't quite right either. So we don't want this as a filter condition, we actually want this as the selection condition. And, no, yeah, so that will be the selection condition. So this will be not as enabled, right? Sounds like is false. But if this condition is false, it's not going to include that P. Yeah. So going back to the spec. So when we say not enabled, we're saying the target is 1, the direction is up, and we're going to look for the remaining possibilities in cell. I can see all the rules that target 1 in the up direction, and they are not enabled. It means it's not possible to pick them. So 0 is allowed to overlap with 1. That's supposed to be true. 1 is the one we're trying to remove, the target. In the up direction. So we actually do want 0 to be returned here, because it would mean that we can't, since we're trying to eliminate 1, we can't pick 0 as a valid value in this cell. That rule. 1 and up here. That's not even a possibility. And there's no other, no other ones in pattern B position with up. So that covers those. So 0, and then in the cell 0 is still a possibility we could pick. So that is one we should remove. That makes sense. And then we keep enabled possibilities. So not enabled for 1 in the down direction in this cell. We say it should be the empty list. So if we look at 1, we have 1 in the pattern B position and down direction. That rule is false, so 0 can't even overlap 1 in that direction. We have another 1 in the pattern B position down. That's false, so 1 can't overlap 1 in the down direction. I have no more. So that should be the empty list. All right. We have no cases where 0 would be a target. Maybe just 1 and 2s. This might actually be working. Although maybe I broke it. That change. Let me just all those tests. Ah, my debug is still running. Let me focus on that one test. Yeah. Okay, we flipped it around. Yes, we should fix those. By removing our not here. That's just reads weird. Is the wrong name. The spec is right. I think maybe the name is just wrong. Well, it could be the spec is incomplete, because we only got like a couple examples here, too. Kind of weirdly named, too. Okay, and okay, let's look at the spec. And so to remove is trying to get them, the ones that are not enabled, or the pattern, the target pattern one in the that overlap in the up direct with one in the up direction. Here are the rules, and this is the cell. So these are all the patterns that overlap with one in the up direction. This one here, and this one here. Okay, now in those two cases, 0, true here means that 0 is allowed to overlap with 1. False here means that 1 is not allowed to overlap with 1 in this direction. We add another case. 2 up, and we should break one test case. Oh, because it doesn't appear in here. Sorry, 0, 2. And 2 is going to be true as a possibility. Okay. Okay. And if I disable true, things should be fine. Yeah. So we enable 2 as a possibility. We're targeting 1. Allowed to overlap with 1, which means if we're removing 1, then the possibilities that we want to remove from this cell, yeah, would be 2, because 2 is a possible member of this cell, a possible value we could pick for it. And then, of course, we have invalid adjacency rules. Because now we need a whole bunch of these. Okay. It wants for 2 in every case as well, so we have to enumerate the whole thing. I'm gonna move these to the bottom here, and down, left, up, right. The pattern's up, down, left, right. Let's see, flip there, there. Good old using runtime exceptions as your assertions. It's good quality Haskell right here. High quality stuff. Okay. Yeah, okay, so I'm getting a little bit better at that. I'm feeling a little more confident about that. That's right. Okay, so what we're saying with not enabled here is that we're trying to get all of the pattern indices that could overlap with 1 that that we should remove because we can't pick it anymore. So we're trying to find, basically we're trying to find all the ones that are overlapping with 1. And we want to remove those ones. So removing them as possibilities. Because not enabled is, I guess the reason why the semantics for this are a little bit odd is because this target pattern index comes from a different cell. And so we're looking at the possibilities of this cell that should be eliminated based on the adjacency rules that target this target pattern index. Okay. Hopefully that makes sense. All right, because we're running quite a bit over time here. So I gotta wrap this up. And we might have to finish this last little bug next week. But at least we have a path to go down here. So let's see. Go to my spec. I'm going to take off the describe here. Focus. Yeah. It's going to hang because we haven't really fixed the error yet. Still getting there. Let's review our changes in the code here. So we have this kind of like debug test code to like kind of catch our error for it, or catch our error for us, but also signify like that we won't when we fixed it. We probably should do through tests, but anyways, that's good. We're removing some debug trace there, going back to that. And that is good. Yeah. Some naming changes that kind of hopefully makes things a little more clear for next time. I'm reading this. Actually, not enabled for is not the right name. It was right before. It's just very confusing how this is supposed to work. So I'm going to add a little documentation here. Of pattern index that overlap with pattern check. This forms this list of pattern index is used to tell which to remove, is used to remove those. So sometimes if you write out even the English language spec, by trying to explain it in a succinct way, it can also sometimes reveal errors in your design of your code, I find. Sometimes English isn't quite precise enough, but sometimes it's good enough. And just by writing this out and trying to tune it, stuff it into a sentence, nature reveals how sloppy your thinking is. That's a pattern from, that's a quote from, or a paraphrase quote from a cartoonist named Gwendon. Nature, writing is nature's way of showing you how sloppy your thinking is. Rubber ducking, yeah. This is my rubber duck right here. It's a not finished model of a Rancor. One of these days, little buddy, I'll finish painting you. Anyhoozle, so this list of pattern index is used to remove those patterns from the cell. Later on. Yeah, exactly. You explain it to the Rancor or the rubber duck. Doesn't have to be a rubber duck, but if you can explain it to them like they're, you know, they know nothing about what you're talking about, then you're probably on the right track. Okay, so returning this list of patterns. So this is the list of pattern indices that we want to remove from this cell. Because the pattern check is being removed from a neighboring cell. Hopefully that's clear enough. Okay. All right, let's update that and just, okay, keep reviewing our code. Added the ordinance. We need that for now. This is the set stuff, which we're going to remove later. Okay, yeah, we updated that code. Removes the pattern index so that we get the pattern stack initialized from get neighbor removals. Right. So we collapsed in the pattern index, we collapsed 2. We then use our get neighbor removals for that cell index, that pattern index. Set that there, okay. Top cell, And there's our debug code there. We modified that there. Okay. 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 Yep, I'm gonna check all this in. It's in a broken state, so master's gonna be broken, but it's just us. It's fine. It's between friends. I'm gonna mark it as such, though. Fixing, elimination, propagation. Okay. There we go. We pushed it up. Thanks for tuning in, friends, and watching and hanging out with me. And, you know, a little bit of helpful backseat programming is also very welcome on this stream. So thank you very much, Swarm Collective and Elemental Magic's card game and everybody else who's been watching and lurking. You're also very much appreciated. All the code for this project that you've seen tonight is on my GitHub. I'm Agent Ultra. I'm Agent Ultra on GitHub as well, under Wave Function Collapse. You can get it there and check it out. Paste that there for you. Bang. Also, if you want to follow me on the socials, I'm on the Fediverse. Check that out. It's got all the links to all my other stuff you might be interested in, like my website, my YouTube channel, where I back up these streams, and so on and so forth. And then you can get updates on like what I'm working on, or you know, when I'm streaming and that kind of stuff, and also random nonsense occasionally. I usually do these streams once a week on Tuesday evenings in the Eastern time zone at about 10 after 8 in the evening and the PMs. And so if you want to follow along and you're on Twitch, you know, you can set your notifications on, you can give us a follow and follow, and then you'll get notified when I go online, or you can just try and remember that and look at my schedule and do all that stuff. If you're watching on YouTube, because you're watching the VODs, you know what to do there. Like and subscribe and thumbs up and leave a comment, whatever you want. You know, lets me know that people are still watching there, and it helps me get some visibility, which is also nice. And all that stuff. What else? The link above my head goes to a wonderful little website that has a link to a Discord server. And so if you couldn't join us on the live stream, but you still want to chat, or you have some ideas between streams and you just want to hang out, talk, there's a channel there for this stream. And of course, there are links to other cool people and other that are also doing streaming in sort of declarative style programming languages like Haskell, and other ones as well. And that's all I've got for this week. So thanks again for watching, and we'll see you hopefully next week. May all your monads be free. Your types always check. Happy hacking out there. Stream over.